Welcome to qnawire.
Problem 11.11. We have someone standing here on a diving board. Dimensions are shown. The diving board has a weight of 280 newtons, which I've already gone ahead and drawn in here halfway along the board. Person's weight is 500 newtons. So what we'd like to do is find the force at the support point here, which we'll call F1. And the force at the left-hand end, which we'll call F2. And we already know the directions of these forces because, there's nothing above the board at this point, so the force has to be coming from below it. And similarly here, I sort of covered it up, but there's just a gap under the board, so it's being supported from the top here, and then the force has to be directed downward. So so we just need to apply our equilibrium conditions, and let's call this point the origin, so all of our torques and things are computed about here. For part A at least. It won't be very helpful for part B, because it'll just end up being 0 everywhere, and that's not so good. So the sum of the torques at this point here equaling 0, or about this point, I mean, you add up all of these things, being careful about their signs. So like the weights of things should be negative, and then this is 0 meters away from itself, so it ends up going away. We don't have to worry about it. And so then you can solve that for F1, and you'll find this. It'll be the weight times the distance of the diver, plus the weight times the distance to the center of mass of the diving board, divided by the distance to the point in question, 1 meter, from our origin point here. So you can see we have that the torque here has to equal the torque downward. This is basically, write that out and then divide by the distance to point 1 to get the force. And so then this has a value of 1,920 newtons. So that's all good. Now, for this, we can use the fact that the other equilibrium condition, basically, the sum of the vertical forces has to equal 0. The sum of the horizontal forces also has to be 0, but there's nothing applying any horizontal forces, so you can add up as many zeros as you like and still end up with 0. We don't need to worry about it. So we end up that F2 is equal to F1 minus 280 newtons from the weight of the board, minus the 500 newtons of the diver, We know all these things. We just found this. These are given. And this ends up being 1,140 newtons.